Benedict, wonderful to have you here. I've followed you for years now, from your days at Andreessen to Mosaic. I've been reading your newsletters, both versions of them, including the premium version, which I think has some really fantastic insights in it. I think you're one of the few people, when it comes to any technology topic, but certainly when it comes to Gen AI, that has been able to frame the future in a way that is both insightful and simple, but also be able to tie it back down to very pragmatic ways to approach it. It truly is a fundamental shift in technology and also in terms of what we can achieve. It's supported by the crazy amounts of money that's flowing in and the growth of this space from $3 billion to $30 billion by 2028, or 90 odd deals just in 2023 alone, with a commitment of over $14 billion going into this space. The cliched analogy of 100 million users in 2 months, it's real and it's here to stay. From your perspective, how did we get here?
How many different ways can I answer that question? I mean, every now and then we kind of have these waves of hyper enthusiasm, and so there was a moment when every big company needed a 5G strategy, and 5G is very real, but most companies actually don't need a 5G strategy. And then we've kind of had crypto and metaverse, which are still a lot to be proven and a lot to be understood there. And we had a wave of AI 10 years ago, which has now, I think, been kind of absorbed into most big companies. There's an old joke that AI is anything that doesn't work yet. And so now that it works, well, that's just pattern recognition, that's just image recognition, that's just translation or language processing. And so every big company now has dozens of AI things, and you don't really think of them as AI anymore. Now we have another wave of AI. And I think everyone, not just in the companies that you're talking to, but I think everyone in Silicon Valley has been walking around holding onto the top of their head with both hands, thinking, oh my God, this is amazing. Long pause, what is it exactly? And out of that, there are kind of different groups of questions. So there's a bunch of kind of technical and scientific questions about how this is going to evolve and what the market structure is going to look like and what it might be able to do and what might get fixed in the next couple of years. And that's kind of obviously one conversation we can have. There's also a set of conversations around, well, where is this useful? What do you do with it if you're not a software company? I think it's kind of interesting to compare this with the last wave of AI, where in 2013 or 14, I would go to big companies and you would say, look, you can do image recognition now. Look, it can recognize cats. And if you're a big supermarket, you would say, well, that looks very clever, but we don't have images to recognize. What is this useful for? And indeed, if you were to go back another 30 years, you go to a big supermarket and explain SQL, explain relational databases. And now you can do arbitrary queries on your data. And they would say, okay, that sounds clever. Why do we care? You go through this process of working out what's the right level of abstraction to understand this? What is this really? What's a good way of understanding what it can do? And then how would you work out where that's useful in your business? And we kind of went through that before with mainframes. And you go through it with databases and with PCs and with the web. And the kind of the last big generational shift in certainly in consumer tech was the iPhone. Obviously, there are some big industrial companies where the iPhone was a big deal, and there are others where, well, everybody who works for us has an iPhone now, but doesn't really change the nature of the product very much. This technology now, I think, kind of cuts across all of those things.
You said two things that I think are really important in terms of what I hear from our customers and in the conversations I've had. One is everybody now feels like they need an AI strategy.
Well, this is like everyone needed an F5G strategy.
Exactly, right? So you have that going on. And then there's sort of the realistic things that you can do with it today that are meaningful. As a C-suite executive or a CEO, how do I cut through the noise and find the signal that says, what can I do with it today? What can I do with it in the midterm and in the long term? We have an internal view of how AI could benefit us as a company and therefore benefit our customers. But given the industries in which we operate, which are predominantly safety critical industries, it has to be much more thought through in terms of our ability to do things like predictive maintenance or guided maintenance in rail and energy versus thinking about safety critical areas like signaling and automated operations of our vehicles. And I feel like many of our customers are in that space. On the one hand, they're saying to their CTO and CIO, hey, what's our AI strategy, right? So there's an element of your hands are not on the wheel, you're delegating that question. And on the other hand, how does an executive know when somebody presents something to me that it's real, it's practical, it's applicable? I feel like those are two sort of bookends, if you will, that I'd love to kind of explore with you.
I think that's right. And I mean, I think there's also a challenge in working out how much of the technology do you need to understand.
Yeah.
When you were thinking about whether you had an AI strategy, and obviously there are some companies that did, if you're in the railway business, an AI strategy is probably a useful thing to think about. If you're in the supermarket business, maybe less so. Yeah. But you kind of need to understand what is this. No, this is not everybody will have gigabit Ethernet with zero latency. This is, it's interesting, but not to that. It occurs to me, there was an analogy I heard someone use looking at the last wave of machine learning where they talked in kind of 3 steps. The first step is you make a gas turbine to go into an oil refinery, and now you will be able to do predictive maintenance and you will be able to analyze the performance of that piece of machinery and maybe spot when something's going to go wrong. The second step might be, now you might redesign the gas turbine, or you might make design changes to how that piece of equipment works. And the third change might be, actually maybe you redesign how the oil refinery works.
Yeah.
And so you've got those successive stages from, this is kind of an incremental operational benefit to the stuff that we basically already do, through to it might change the product in important, interesting ways, through to this might kind of fundamentally change the nature of our market.
Yep.
Generally, every new technology is disruptive to somebody in each value chain, not necessarily to you. So kind of another big example from a different industry is online flight booking completely transformed the travel agency and basically destroyed the travel agency. Yeah. It didn't really change the airline business.
No, it's true.
They need to think a lot more about loyalty and air miles and so on. But the basic business is buying very large airplanes and buying fuel and having travel slots and so on. And that side of the business doesn't get changed that much. And so you have to kind of think pragmatically, which of these is this going to change and where? Obviously, some of the people watching this are in industries where actually the whole structure will get fundamentally changed by this. Clearly, people who are in the copywriting business or the graphics business, or indeed the newspaper business, having very sort of serious thoughts about what this is going to mean for the entire nature of their business. Yeah. There are other industries where it will make it easier to do the maintenance.
You touched on this, Benedict, and I just want to explore it a little bit further, is the lens we use from Hitachi. And some customers I've seen use this as well, right? Is sort of 3 to 4 categories, right? One is, what can it do for me today? And it could be efficiency, optimization, automation, sort of very direct impact to your business, to your supply chain or your operations. Then there is things that it could do to enhance what I do, right? Make it better, derive more value from what I do today. Then what are the new things I can do? What is the innovation that enables, or the millions of new apps that can get generated because of the access to this technology? And then there is sort of the existential, what's the future of AI and so on and so forth. As CEOs or C-suite executives, AI is a technology where you can't delegate. You actually need to have hands on the wheel, right? Meaning you have to be in it and you need to understand it in order to shape it for your company. And so how would you help me, or how would you have me think about it?
So it's kind of useful also just to kind of think about what is it that this thing is doing and how does it work, and what useful ways to abstract thinking about that. The historical model of thinking about automation is that you find some task and you abstract it away. So you never get kind of a steel workman walking around a factory doing what a human workman would have been doing. You get a machine tool or a conveyor belt or a bicycle or a crane or something. So you abstract that task away and you kind of simplify it into a series of logical steps. The way that you could describe that is there are tasks that are hard for people to do but easy for people to explain. So it's very hard for me to calculate a mortgage in my head, let alone calculate it a million times. It's quite easy for me to write down the steps for how you would do that. And so that's sort of automation from the beginning of the Industrial Revolution through to really computers in the 60s and 70s and 80s. But what you also have is a class of problem where it's easy for people to do, but very hard for people to explain how they do it. So why is that credit card transaction weird? Why is this better than that? The classic formulation was, how can you recognize that that's a cat and not a dog? And you would think it would be quite easy to explain how you recognize a cat and not a dog until you try and do it. And then you realize 5 years later, you've written 3,500 logical steps and it sort of works, but it never actually works. And I used to describe that as being a bit like trying to make a mechanical horse. Like theoretically, there's no law of physics that says you can't make a mechanical horse. And in practice, the degree of complexity would just become completely impractical. And so then the breakthrough of machine learning now kind of a decade ago was to say, instead of making this a logic problem, we make it a statistics problem. So we give the computer all the data and we give the computer the answers, and the computer works out the rules. So the computer works out what those steps would be. And so that worked fantastically well for kind of a whole class of things where you could give it patterns. And that's what got us image recognition, language translation, and then all the other things that every other company is doing. Anything where you can find patterns. And very often, of course, the challenge was you didn't necessarily realize that you had those patterns, or you didn't even realize that that was a problem because it was unsolvable. And so you'd never even tried to automate it because it was so obviously impossible that you'd kind of never seen the problem. An example of a company I saw a couple of years ago, which was using image recognition to analyze the maintenance and steps done when an aircraft, an airliner arrives at the gate.
Okay, yeah.
And so you would think that sounds like a checklist problem. That's like a documentation problem. So maybe it's iPads or it's better software. And they said, no, we'll use image sensors. And the image sensors will be able to gather the data on what people are doing. You wouldn't have thought that's image recognition. It doesn't even sound like pattern recognition. But you are able to automate that using machine learning. And so we're now kind of going to go through another of those steps where there was kind of, to your framing, there will be the immediate, easy, obvious stuff. There will also be stuff that kind of emerges out of this that people hadn't realized were things might be addressable with this. I think one of the useful ways to try and think about where you might find these opportunities is to think about interns. So if you think about the last wave of machine learning, imagine you run a call center and you would like to listen to every call that comes into the call center and tell me if the customer's angry or if their service agent is rude. You don't need an expert to do that. You just kind of need a 10-year-old or a 15-year-old. But you can't listen to every call. You've got 1 million calls a day. And so machine learning gives you kind of 1 million interns. It gives you infinite interns who can just do that thing. What they can't do is do what the creative director does. They can't do what the 40-year-old does, but they can do what a 15-year-old would do. And you would have to check it, but it's still tremendously useful to have that capability. And I think the same thing now comes with this wave of machine learning, with generative machine learning. Make me 200 ideas for that thing. Make me 500 ideas for a copy line. Make me 500 ideas for a Facebook ad. Make me 250 plans for this thing. And I will then go and check them, and a third of them are just useless, a third of them aren't very good, a third of them are interesting. And that's still much more efficient than me sitting in a room with a blank piece of paper and a pen, staring at the table and coming up with 100 or 200 of those ideas. And so again, it's an intern. You get the intern to write the thing. You don't then just put it into production. You check it. But it's still useful. It would be useful for most people watching this to have 1,000 interns.
Yes. As an executive, you want to think of yourself like, if I had that type of capacity behind me, then how would I apply it against my set of problem A, B, C, or D, or opportunity A, B, or C?
Or, another example is what would happen if you had a $50 million budget for McKinsey every year? And you could just spend that on McKinsey every year. What problems would you throw at them? Some of the work would be better than others, but it would still be quite useful to throw 50 people or 25 people at that problem for 3 weeks and see what comes back.
That's interesting. One of the CEOs I was speaking with had requested his team to go off and come back with a set of use cases prioritized in the model that we talked about in terms of sort of today enhancements and then futuristic in terms
today,
of working.
next year, 5 years.
Exactly, right? And it took them about 3 weeks to come back. In the meantime, the idea popped in his head to say, let me just go to GPT-4 and run the same query by it. And he said within 5 minutes, he got a set of ideas or use cases from GPT-4. And then when his team came back, he looked at the two. He said, they're pretty much the same. So 1 to 3 weeks, it's a real world example, but also to the point that you're making, it really comes down to how do you query it. If you're asking it the right way, if you have the right way to frame your question.
You have to work out what question to ask.
I
mean, this is kind of the point about, supposing you show relational databases to a supermarket in 1978. So you go into the meeting and you say you'll be able to do arbitrary queries on your data. And they'll say, like what? And you say, well, you'll be able to look up your customers by zip code. And they'll say, well, we don't have our customer zip code. Now, of course, you could explain very clearly all of the different ways the supermarket industry has been completely transformed, first by mainframes, then by things like SAP and Oracle and so on. But it takes a while to work out, well, what is this useful for? What would we do with this? I think the other core issue for an LLM is to understand that this is not a database and it's not a mammal, it's not a human being. It's doing pattern recognition and pattern generation. And my favorite example is, I went and spoke at a conference and they generated a biography with ChatGPT and sent it to me, and they didn't tell me. They just said, is this a good biography? And I looked at it and said, where the hell did that come from? Because that's half of it was nonsense. So a lot of people's initial reaction to these things is your first reaction is, oh my God, this is amazing. Your second reaction is to say, oh my God, this is talking total nonsense. And you have to try and work out, well, what is it that it's actually doing?
Yeah.
And it's not answering your question. What it's doing is it's saying, what would answers to questions like that tend to look like? It's taking the pattern of your question and the pattern of an answer. To the biography, if I go to ChatGPT-4 and now ask for a biography of me, it will say I'm a hugely influential, world-renowned analyst, which is obviously correct.
Of course.
And then it will say I did history at Cambridge and worked for The Guardian and the FT, and then went and worked for this research company. I did do history at Cambridge. I didn't work for The Guardian or the FT. Then I'll hit reload. Now I went to LSE and I studied economics, and then I went and worked for The Economist. Reload. Now I went to Oxford and read English, and what it's doing with all of those is they're always the right kind of degree. It's always the right kind of job. If you were to do it, it would be the right kind of university, and it would be an engineering kind of a job, and it would look like you.
Yeah.
Because if you understand what it's doing, it's trying to make a pattern that looks kind of like the pattern that you gave it.
Right.
And so there are some kinds of question in some fields where that's absolutely brilliant and incredibly useful. There's other kinds of questions in other fields where that's basically useless. So me as kind of an analyst, what I would really like to do is, there's a chart I would like to make, which I would get by compiling data from sort of 60 years of US Census Bureau PDFs. And I'd have to find the PDF one at a time and find the page and type it in. It would take me like 3 days. Presume for the sake of argument those PDFs are all in ChatGPT. I ask it the question, will it produce that chart? Maybe, maybe not. It might produce the chart. What it might also do is tell me what the chart like that would probably look like.
Yes. Yeah.
Which is not actually what I want.
Yeah.
It's the same conversation we had with the last wave of machine learning. It's got an error rate.
Yeah.
You ask it to recognize X or Y, it will do that with a 93% accuracy. And you have to understand that last 7%.
That's right. Yeah. Touching on what I at least view as the arms race now with the big four or big five. If I am a C-suite leader in an industrial company or in Fortune 500, why do I care and why do I not care about the arms race?
There's sort of two categories of question. There's a category of question which is, what does this mean for you and everybody you work with and all of your peers and competitors? There's a second category of question which is, how is this technology going to work? Who's going to win? What's the value chain going to look like? What are the competitive dynamics? What happens to the error rate? What products get built? There's all basically the Silicon Valley questions.
Yeah.
And the core of the issue here is that, first of all, this stuff sort of only started working a year ago. It started working because OpenAI realized that this might work and did it kind of first at a much greater scale. And now everyone else is kind of trying to realize that insight and trying to catch up. There is no primary science that OpenAI has and no one else has. Core concepts are all pretty well understood. There's no a priori reason why there won't be lots and lots of models, except that the way the model works is you give it basically all of the data that there is, like all of it, like something like a third of the web, plus a lot of other stuff. Yeah. And so doing that is expensive and time consuming. And so the first kind of science technology question is, are we going to have, so to speak, 3 giant foundation models that cost an enormous amount of money to build and run, and everything else is kind of a thin plug-in on top of that? Almost like kind of mainframes in the 60s and 70s. Your company has a mainframe, and that's it. Or is it going to look like databases or spreadsheets, or indeed the last wave of machine learning? If I were to ask you, how many spreadsheets are there inside Hitachi? It's a meaningless question. Indeed, how many databases are there? Again, it's kind of a meaningless question. And that's what's happened with machine learning. So this is one of the questions, is generative machine learning going to evolve like that? In which case, or not. And so it may be that there are 3 big LLMs, 3 big foundational models, and everything else sits on top of that. Yeah. And so whoever you are, whatever it is you're building, your stuff is running on top of OpenAI and you're paying them a fortune to run your stuff. Or it may be that your IT providers of choice go and take open source components, mix them up and make you a thing, plus you buy stuff off the shelf, and some of it's running on OpenAI, but in the same way that some of it is running on AWS. Right. And there's a sort of a spectrum between those where people will argue about what might happen, but nobody honestly knows how that's going to evolve yet. This is also kind of the open source question. Yeah. So Meta, where OpenAI and Google have their model inside and sell access to it, but they keep control and access to the core data. Meta, because they don't have an enterprise cloud business, decided, we'll just
let
give
me
ours
help
away
you.
for free. So they made open source what's called their Llama model, which is like Google's Bard, not as good as ChatGPT-4, but not that far off. And then there's a whole argument, the dynamic of open source mean there'll be massively more innovation that will catalyze around that, and that will become the dominant model, or maybe other open source models will become the dominant model or not. What does this mean for, a big industrial company? It's the difference between you can own all of your tech actually has to run on Oracle, or somebody paying Oracle. Or you've got a choice of 500 vendors and they might be on AWS or they might be on this or that and you don't have to care, which is obviously what enterprise SaaS looks like today.
What I take away from that, at the beginning, the Hitachi CEO really got his hands on it very quickly and continues to do his homework in terms of what are all the permutations of this, right? And how does it impact each of our businesses given the scale of the business? And then where do we start and what do we do? As a C-suite leader, you need to do that because of the breadth of different things that are available to you and your ability to be able to target what's right for your company and then also try to figure out what's the right technology or what's the right LLM and do I even need a foundational model or are there other ways for me to get at this?
I think that's right. And I think, you can compare this with the last wave of machine learning. You can compare it with databases. You can compare it with PCs. Yeah. It's a sort of a generational shift in how software works and what software can do. Yeah. There's sort of different levels of excitement about this in Silicon Valley. There's sort of a base case says, okay, this is a new machine learning. It's a new iPhone. It's a new web. The once every 10 or 15 year generational shift in how computing happens. And just as for the last 10 years, all software was built on machine learning and built on the iPhone, for the next 10 years, all new software companies will be built on generative AI. And sometimes this will be a feature of existing companies, and sometimes this will enable new companies, just as happened with machine learning. And then in 10 or 15 years' time, there'll be the next thing will happen, which has sort of been the pattern for the last 50 years. There's a much more aggressive view, which is actually what Bill Gates has been saying, is this is more kind of like the graphical user interface. It's a once every 30 or 40 or 50 year generational shift. And the reason he mentions the GUI is that when he went to Xerox PARC in the late 70s and saw the GUI for the first time, he realized this was a step change in who could use computers because you wouldn't have to learn command line prompts to key into the keyboard. You could just click on what you wanted. And so there was a fundamental change in how many people could use computers. However, somebody still had to have written the software that you're clicking on. So either the tool already existed or you had to pay somebody to make it for you or something. Whereas with an LLM, in principle, you can just ask it to do the thing. Or you can ask it to make a tool to do the thing. And so it expands the number of those dedicated tools massively. I mean, kind of back to my example, I want to get this data out of 50 years of census reports. The US Census has an API. So theoretically,
you should be able,
but I can't do that. I'd have to pay someone to go and write the code and work out the API and the 5 different or 15 different databases that they use. And a couple of $1,000s later, I'd get the output and maybe it'd be good, maybe it wouldn't. In principle, I should be able to go to ChatGPT and say, go extract that data, make a tool to extract that data, or make a tool that uses the Census Bureau's API. Here is the API, this is what I want it to do, and it should be able to do that. And, we're not quite there yet, but that doesn't seem like science fiction. That seems like something that's eminently achievable quite soon. And so that's a sort of a fundamental step change in what software could be doing within an organization. It's also a fundamental step change in going further down, your framing, how it is that the actual business and the product could be being created in a couple of years' time.
I really love the interface argument in that it's inherently easier now to have a conversation with something that can actually do things on your behalf and come back with answers, as long as you're framing it properly. The other question around all of this is, as a company starts to think about investing in this space, how do they start to think about, whether it be organic or inorganic investments, right? How do they start to think about how and when to invest? A couple of companies, they started to build a set of features, using a foundational model, and then Code Interpreter came out, and that sort of kind of killed that entire.
Welcome to my life. I mean, you're not the only person worrying about this. I mean, this is the kind of the challenge of investing in startups in this field. You have the companies that are spending tens and hundreds of millions of dollars building stuff, building hardcore software and like data centers. I mean, NVIDIA is going to sell, what, $20 billion of GPUs this year?
Yes.
And 2 years ago, who outside the games industry had heard of NVIDIA, really?
For GPUs.
Who outside of the tech industry had heard of NVIDIA? So there's a kind of enormous kind of capital intensity and gold rush of making the foundation models. The other side, every day there's another 10 tools based on generative AI, and they're all basically quite thin wrappers on top of Bard or Llama or ChatGPT or Hugging Face or something else. So they're very thin wrappers on top, and it's challenging to see how that would be a company. And of course, also the challenge of building a thin wrapper on top is they might change how it works tomorrow. So your thing might stop working, or they might make something that competes with that or something. And the kind of the underlying point here, of course, is this whole thing is just happening very, very quickly. Much more quickly actually than the last wave of machine learning, which quite a slow burn from sort of 2013 maybe to 2015 before you really had waves of big companies being created. With this, it's like standing on the shoulders of giants moment, because you have all of the stack of the tools for the last wave of machine learning already there. You have these big data sets because you're already doing stuff with them. You have GPUs, you have enterprise data centers, you have SaaS. And meanwhile, you don't have to go out and wait for everyone to buy a phone. So compared with, the iPhone, which we think of as this incredibly quick thing, well, Apple announced the iPhone in 2007. They didn't really sell in volume until 2010. It took kind of till 2015 for sales to really get over 1 billion units a year and for this really to become something that everybody on earth is going to have. Whereas with this, it's just a web page. So you've got this kind of phenomena that, there's a sort of an outside estimate that ChatGPT had 100 million users in like 6 weeks. Which is like nothing else has ever happened that quickly. But then you can't really just go to ChatGPT and use it to replan the layout of the signaling network for a national rail system.
No, exactly.
So there's like a pause of like, you get from that, which is really, really cool and useful for some things, to work out, okay, what is an enterprise scale product going to look like? And how long is that going to take, and what would you have to build around that?
There's this FOMO moment. Everybody wants to be a part of it because of the fear of
it's a 5G strategy.
Out, right? The 5G strategy, right? Frame that for us a little bit. Do you need to be running today, and it's just a couple of weeks, and do you feel like you're behind?
So we'll struggle to keep up with everything that's happening. Basically what I need is an LLM that will summarize this week's papers so that I can catch up with what's going on, and also catch up with superconductors and everything else that's maybe not happening. You can get overwhelmed by the noise here, but there are clearly basic foundational questions. How are these foundation models going to evolve? How is the error rate going to evolve, and so on? I think if you're in a big company and you're not in technology, you don't have to be on top of all of that detail. Should you be having pilot projects, or should you be putting stuff into production? Well, it depends a huge amount on what you're doing. So I saw at Cannes Lion, one of the big ad agencies was working with a company, kind of a CPG company, that has thousands of partners in Latin America running barbecue stalls and burger stalls and things. And they wanted a way to give all of those individual people owning this one stall or this one cart a nice custom poster or a nice custom wraparound to go around their cart. But they wanted them all to be unique. And so they use LLM to generate iterations on the graphics and iteration on the slogans to put on it. And then they sit and look at them all. Which is also an important part of the story is, you make 1,000, you pick 500 of those and choose which you are good. So there are some places where you can just take this and use it now. This will probably be very interesting for doing a nationwide signaling layout or thinking about, exactly how you build a large electric motor. But that's not today. That's going to take a while. And I don't think you can kind of know that unless you're inside the company. My joke about these kind of questions sometimes is that sounds like an RFP, and that might be an RFP for McKinsey, or it might be an RFP for Accenture, or it might be an RFP for a very specialized engineering company, kind of depending on where you find your opportunities.
Benedict, it's just been quite a bit of fun. Really, really enjoyed our conversation. It's crazy because we've talked about this a lot, and still we're just scratching the surface of what this could be. And I'd love to be continuing this conversation with you over time.
It's nice
been
to have new
wonderful.
questions.
For executives that are listening in, what are 2 or 3 things they should think about? If they want to lead the charge, but yet do so, with an eye on the future, but be pragmatic about their approach, what would you recommend?
So I think I said earlier, there's an old joke in AI research that AI is anything that doesn't work yet. And you could also say, once technology works, it's just automation. And all the stuff that was high technology 20, 50, 100 years ago is now it's just automation.
Yeah.
And this is kind of another wave of automation. It's a wave of automation like we had with machine learning or with PCs or with mainframe computers or with typewriters and adding machines and machine tools and production lines. It's another sort of fundamental wave of innovation that will roll across companies. There will be some parts of the business where that's a big deal and some where it isn't.
Yeah.
That's okay.
Yeah.
A few years ago, I spoke to a large water company and the chief exec said, I think this year, I think innovation might be one of our top 5 priorities. Which sounds insane until you think, yeah, but it's a water company.
Yeah, no.
They may have other priorities.
Fair enough. No, this is super helpful. Again, thank you for your time. Really enjoyed it and look forward to future conversations.
Thank you.
Thank you.